So those who are present in the last session, we talked about we actually started with this third unit, right? That is machine learning models. Okay, and from that, if you people remember, we have already seen theory part regarding linear regression, in which I have actually shown you one example, right? And if you remember, we have taken the data in which we were having input column as x and output column as y, right? So if you remember, x was the ratings given by the people, different people for the movie Bahubali Part One, and y was the rating given by people for the movie Bahubali Part Two. So we assume that this is our input and this is our output. Okay, it was a very smaller data, and with the help of this data we actually try to make use of linear regression, and we try to predict that, okay, if some person gives 3.5 as a rating out of 5 to Bahubali Part 1 movie, what will be his rating for Bahubali Part 2? So something like this we have actually seen in the last session. Those who are present, I hope they will remember it. Okay, so just to continue with that, what I will do is I will just try to show you the implementation of linear regression in Python. Today, that's what I am going to talk about. So, in that particular process, actually, you will be able to see some of the steps which we generally follow in developing the machine learning models, right? So, uh, with relation to this particular topic, and in that we will also talk about this one also, least square methods, right, and multivariate linear regression. So we will try to cover all these topics, but before that we will just try to go and we'll try to see the implementation of linear regression in Python by following the same theory, right, by making use of the same theory concept which we have seen in the last session, right. For example, if you people do not remember, see, what I have done is whatever I have taught you in the last session, for that even you will find out, if you go and if you just Google, right, same example I have actually explained on my YouTube channel here. So maybe this is I'm just trying to talk about this particular thing just because it might be very useful for you people for your exams. Okay, let me just skip this particular thing. Here what I have done is I have actually shown the numerical, same numerical which we have discussed in the last session, right. So if I go and if I try to show the data set, see, this is the data set which we have actually talked about in the last session. So for your exam, you might get a question like, you will be given this type of a data, right, this type of a data, and you will be asked if the value of this x is 3.5, what will be the value of this particular y. So all the steps are actually shown in this video. By chance, if you have any mistake, you go and you refer this. Otherwise, I have already explained you this particular thing in the last session itself, right. So this is what you can actually search, right. So you go and you refer it if you want, right. But yes, obviously for your exam point of view, that is somewhat important, because linear regression is a topic which is mentioned in your syllabus. Linear model is a topic which is mentioned in your syllabus, and the part which is explained here is a theoretical part which one needs to know to understand linear regression, right. So that's what we have discussed in the last session, right. Now, as I told you, today I'm going to go one step further and I will try to discuss the implementation of linear regression. So straightforward, what I will do is I will try to show you a problem statement. See, we have some data set. Now you people are very much aware about some of the input file, like you are aware about .csv file, right. In the first few sessions only, or in the starting sessions itself, we have talked about csv. Csv stands for comma separated value, right. So your input can be in a csv file, or even your input can be in .xl, or we call it as .xlsx, right. So input can be in any of the format, even in javascript object notation and so on. So what we are going to do now is, uh, just to implement that linear regression here, I'll be making use of a CSV file as input, right? So in our input is going to be CSV file, and in that CSV file we are having some 8 to 9 input columns and one output column. If you people remember the example which we have seen in the theory, in which you are having x as the input and y as the output. So we were having only one column, only one attribute as the input, and only one attribute as the output. But the example which we are going to implement, in that example, more than one column is going to be input, and that's what is going to happen in real time, right? That's why I have chosen actually that kind of an example here. So let me show you the data set itself. The data set which I am going to make use of as a input. Okay. So for linear regression, as we are going to develop one model here, right? Just try to understand what are the steps which we are going to follow at the start. See, just assume that initially client has come up with a problem statement, right? And client has given us this particular data. So first of all, what we will do, we will try to understand what kind of a data set is it, right? And then I will try to talk about what is the problem statement and what client is actually expecting from us to implement. So if you see, there are different columns here. For example, here it is serial number, right? Let me just highlight each one of them. So you can see serial number is the first attribute or column, or we can call it as what we can say is attribute or a column or field. We can say serial number. Then GRE score is another one, or feature we call it as, right? Then TOEFL score, then university rating. SOP actually stands for statement of purpose. I will tell you what it is actually. Statement of purpose. Always remember, whenever you want to develop any model, okay, any model, it might be a classification model, it might be a prediction model. One needs to understand the data. Understanding data is very important. If you are not aware about what type of data it is, and what about that data is, you are never going to, or it will not be that much easy to develop model for you. So understanding data itself is very necessary. So SOP stands for statement of purpose. LOR actually stands for a letter of recommendation. Why it is used, some of you might be knowing about it, but still I will explain it. CGPA is nothing but marks, right? You people are already aware about CGPA. It is nothing but marks. Research, that means whether a person has done some research or not. So one means yes and zero means no, for example. And what is the chance of admission? So 92%, 76%, 72%, based on all these input features. So let me explain you what all these data are about. So this is the data of the students who applied for masters. Okay, for example, maybe to take admission in masters in foreign university. Right now, this is the historical data. This is the data of the students who already tried out. Right now, first student. So how many marks he has scored in GRE? You might be knowing GRE is the exam, right? Which is actually considered whenever you want to go for MS masters in foreign universities. So many of the universities actually they consider GRE score. I hope every one of you might be aware about GRE. So generally, the GRE is out of 340. Okay, so out of 340, first student has got 337 marks. TOEFL is also another example of an exam which is actually considered whenever a student wants to take admission for some foreign university in some foreign university. So TOEFL score is out of 120 marks. So first student has got 118 marks in TOEFL exam. University rating is nothing but, for example, you are studying in your in whatever the university you are currently studying, right? For example, world-based university you are studying in right now. So, what was the rating of that university, right? So, rating is out of 5. So, for example, the first student, the university in which he has studied, the rating of the university was 4 out of 5. Okay. SOP is like what? You might be knowing the people who go for PhDs or research or MS, most of the times they are actually asked about the statement of their research or statement of the purpose if they had done something, right? So statement of purpose is again out of 5. So first student has got 4.5 for his statement of purpose. Okay, and everything of this is going to matter. It is going to be very important to get the admission to foreign university for that particular student. It is going to improve the chance of the admission, right? LOR is actually letter of recommendation. So letter of recommendation is generally given by the principal of the institute, or maybe the HODs, or maybe project guides. Again, it is on the scale of 1 to 5. CGPA is nothing but your marks, it is out of 10. And research done or not. This is actually a categorical column. What do you mean by categorical data? It means like it has only two values, right? For example, uh, it has only two categories: research done or not. That is yes or no. For example, yes is 1 and no is 0. So, right? So it's a categorical data. All other columns, if you look at, they are actually continuous columns. Some of them they might be categorical. For example, maybe university rating is on the scale of 1 to 5. Yeah, you can take it as categorical also, because there are only 5 values: 1 or 2 or 3 or 4 or 5. So other than these values, there is nothing. So it can be categorical. It can be taken as categorical. But yeah, this research done or not, yes or no. So you might be knowing that the basic thing, you talk about any machine learning algorithm, the basic requirement is that your data should always be in numerical, right? So always remember this point. Before applying any machine learning algorithm, always remember few points. The assumption is that, first of all, whatever the data you are going to make use of, right, for creating the models and for applying the algorithms on that data, always remember that your data should always be in numerical format. It should be numerical. That is one thing. Another thing is that your data should be normally distributed. Now, what is normal distribution? That is another part that we might discuss when we will see the implementation. When we will start with the implementation itself. Okay, so your data should be normally distributed. These are the two things which are always assumed before applying any machine learning algorithm. So, normal distribution or normally distributed, we can say. So your data should be in numerical format and your data should be normally distributed. Now, what do you mean by normally distributed? It means that if you go and if you try to uh, plot some graphs for your data, for example, distribution plot. There is a plot called as distribution plot. You can actually plot different plots with the help of some packages in Python. Like you have the packages like matplotlib. I have already shown it in the implementation, even though we did not discuss about it. But yeah, in this example, I have already shown you how to plot different plots for this particular data. So you have the packages like matplotlib and cbon, with the help of which you can go and you can actually plot distribution plots. So what do you mean by normally distributed data? It means if you go and if you plot the graph for your data, the graph is going to look something like this. This is called as normally distributed data or symmetrical data. It means the data can be equally divided. Right? This is called as normally distributed data. So your data should look like this. The distribution of your data should look like this before applying any machine learning algorithm. But if the distribution is looking something like maybe something like this is not called as normally distributed data. This is called as skewed data. Okay, there is some skewness, and it is called as rightly skewed data. And even it should not be something like this. It should not be something like this also. This is called as left skewed data. Okay, so always remember your data should be normally distributed. That means something like this. And see, this is called as normally distributed. If I want to tell you what is normal distribution, so uh, for normal distribution, the mean is always zero. Mean, that is mu, is always zero. Mean is nothing but what? Average. Okay, and standard deviation can be anything. For example, 1.2, 2.2, something like that. But there is one more variant talking about normal distribution, and that is called as standard normal distribution. Okay. So what is standard normal distribution? Standard normal distribution is normal distribution itself, but there is a little difference. Normal distribution looks like this, but standard normal distribution is always centered around zero. Okay, so this is called as standard normal distribution, where mu is zero, but standard deviation is always one. See, this sigma sign is actually used for standard deviation. Now, what do you mean by standard deviation? Standard deviation means how much other values actually deviate from the mean. Suppose this is 1 point, so how much this is deviating from the mean value, right? I told you for standard normal distribution, mean is always zero. So if you are not aware about all these things, don't worry. But remember some of the points like standard deviation. It looks like this. And sorry, normal distribution, it looks like this. And standard normal distribution is always centered around 0. And whenever I say standard normal distribution, mu is 0 and sigma is 1. Mu is nothing but what? Mu is nothing but the mean or the average, and sigma is nothing but standard deviation. See, I am not going and discussing all these things in deep because these are not the things which are mentioned in your syllabus, right? But yeah, just to have you an overview of all these things, that's why I'm just trying to touch all the points, right? So it should not happen that why am I actually trying to find out the standard deviation? Why am I trying to check whether my data is normally distributed or not? So that's what we will be doing in our implementation. Remember, see, what I will be doing is, first of all, I will check whether the complete data which I got from the client, whether that data is in numerical format or not. If yes, then only I will check. After that, I will check whether my data is normally distributed or not. See, what will happen if your data is not normally distributed, and if you try to train the model from that data, what will happen because of that? You will get the model. Definitely, you will get the model, but you will get overfitted model. If you do not check whether your data is normally distributed or not, right? It should be model. Okay. If you do not check whether your data is normally distributed or not, and then you go and you train the model, definitely you will get the model, but that model is going to become overfitted model. Now, what do you mean by overfitted model? It means while training it will give you good accuracy. For example, it will give you 95% of accuracy while training, but while testing in real time it might give you less accuracy, maybe 70%, 74%, and that's what we do not want. And that's why in advance only we try to make sure that our data should be normally distributed. That's what we are going to do in the implementation. So remember this one. Okay, first point is that your data should be in numerical format. So if you check this complete data set, everything is in numerical, right? So it was earlier it was like this: yes, no, yes, yes, because one is yes and zero is no, or you take anything, no problem. But what we have done is we have actually already converted y and n or yes and no into one and zero respectively. That's why you are able to see this particular, right? So yes, everything is in numerical format. That is one thing. Later on, we will see whether it is normally distributed or not. Right? So I hope everyone has got the meaning of all these features. The serial number, see, now serial number is not going to contribute to the chance of admission. What is chance of admission? So if you talk about first student, if you consider all these features for the first student, right, his chance of admission was 92%. Similarly, second student, third student, fourth student, and so on. Right. So this is the data which is given to us. Now from this data, with the help of linear regression, right, we need to create such a model which is going to help us to predict what will be the chance of the admission of a student if he enters all these features. For example, new student comes and suppose he has got maybe 311 marks in GRE. In TOEFL, he got 119 marks. University rating is 4. SOP is suppose 4. Letter of recommendation is 3. CGPA is suppose 8. Research, yes. So, what will be the chance of his admission? This is what our model is going to find out. So, this kind of a model we want to create, we want to train from this particular data set. I hope everyone understood the problem statement. Is there any difficulty, anyone? You just let me know in the chat box. If anyone having any difficulty in the problem statement itself, just let me know in the chat box. You might be having any simple question, no problem. I'm just asking you, is there anyone who is having any doubt in the problem statement itself? What are we going to do? Have you got it, everyone? From with this data set, what am I going to do? Is it clear, everyone? Can you just let me know? Okay. So, okay, Monisha is saying, sir, we will be using multiple linear regression. Multiple linear regression, that's what we will be using, Monisha. You are right. Because see, if you people remember, okay, I think I got reply from Monisha and Sharon. So people are saying yes, they are getting what is the problem statement. Okay. So Monisha is saying, are we going to make use of multiple linear regression? Yes, Monisha, because if in the last session, if you remember, what we have seen is we have seen this particular equation for a straight line y is equal to mx plus c. Right now, I have written it like this: y is equal to b0 plus b1x. So where this b1 is the slope and b0 is the y-intercept. Now, what are we going to make use of these? We are going to do something like this: y is equal to b0 plus b1x1 plus b2x2 plus and so on bn xn. So what is this n? N is nothing but number of features. So it is going to be multiple linear regression. So you know, in my case, how many features we are going to make use of? 1, 2, 3, 4, 5, 6, 7. These 7 are going to be my input features. So it is going to be till b7 x7. I did not consider serial number because I know that, see, later on what are we going to do is, before applying linear regression, I am going to drop this particular column from the data set. Once I import this particular data set in Python with the help of Python in data frame, I am going to drop this particular column because I know that serial number is never going to contribute to the chance of admission. Serial number is never going to contribute to the output column. That's why I am going to drop it. So yes, Monisha, to answer your question, we are going to make use of multiple linear regression. And something like this we are going to make it. Internally equation is going to be like this. Because in the example which we have seen in the theory in the last session, it was like what? X and y, only one input, only one output. But here input columns are more, and it should be actually right. Your answer should not depend only on one column or only on one feature. So is it clear, Monisha? Does that answer your question, or wanted to ask something else? Yes, Monisha, can you just let me know, is it clear? Okay. So yeah, so this is what is going to happen in the background. Now, as I told you that while implementing, I am going to drop this particular column serial number. So obviously, to drop that particular column from the data set, first of all, what I will need to do is I will have to import the complete data set as a data frame with the help of Python. So for that, if you remember pandas package, right? Pandas can be used to import any data set in Python as data frame. So, and even I also told you, whatever we are going to import, maybe from CSV file, maybe from Excel or JSON, ultimately it is going to be considered as a data frame in Python, right? So that's what I am going to do now. Before that, let me just show you how many number of columns and how many number of records are there. See, serial number 1, then GRE score 2, then 3, profile score, university rating 4, SOP, statement of purpose 5, letter of recommendation 6, CGPA 7, research 8, and chance of admission 9. Now try to understand, out of this is not going to contribute to the output column. What is our output? This is going to be our target column. Okay, just make it clear. Target column, or I can call it as output. There are different terminology which can be used. We call it as target column, we can call it as output column, we call it as label. Okay, and all these other columns, we call it as inputs, or we call it as features, right? Or they are also called as independent column or independent features. Inputs, features, independent features, they are also called as attributes, and this is called as dependent. Okay, dependent column. So target, output, label, or dependent column is one and the same. Inputs, features, independent features, and attributes is one and the same. I hope everyone is able to understand what is going on here. Right now, let me show you. Once we have seen all these columns, let me show you how many number of records are there, how many number of observations are there, how many number of rows are there. So if I go and if I try to show you, you can check it that approximately we have got 500 number of records, right? Records, or we call it as observations, right? So see, 500 number of records. So obviously, as many number of records are available, it's always good, because see what's going to happen now. We got 500 number of records, but in real time, 500 number of records is actually a very small number. If you really want to go and if you want to create a good model, definitely 500 number of records is not enough for that. So, but yes, obviously, just for your understanding purpose, what I can do is I can take it as a complete data set, right? Just for understanding purpose. Now, as we have 500 number of records here, just try to check each and every column. What kind of a data is available in each and every feature? Serial number, okay, anyway, we are going to talk. Just look at GRE score. Now, if you look at GRE score carefully, you will find out some of the cells are empty. See, there is no value here. Similarly, there is no value here. There is no value here. So these are like what? These are like empty values or missing values. I hope you people remember the concept of missing values and why it is necessary to handle missing values. I already talked about it in our starting sessions, right? So in GRE score, you have missing values. Similarly, you have missing values in university rating. See, there is a missing value. And like this, if you go and if you try to check in some other columns, I think in TOEFL score also we have some missing values, right? But obviously, one is not going to check all these things manually because it will not be feasible to check the things manually like this. Because why it's not possible to check all the things manually? Because the data is going to be very huge in real time, and that's where we need the packages which are actually provided by Python. Those are going to be very handy, right? And the packages like NumPy and Pandas I'm talking about, and Matplotlib and Seaborn. How? That's what I want to show you. And that's what we will be talking about in implementation. But remember, see, GRE score is having missing values. TOEFL score, I think it has missing values, and university rating is also having missing values. Now, just to remind you why to worry about missing values, because see how many number of records I have shown you. I shown that there are 500 number of records, but if I go and if I try to count number of records in GRE score, definitely it will be less than 300. Why? Because if you remember, count function always ignores missing values. For example, there are 15 missing values in GRE score. So the count of records in GRE score column is going to be 485 and not 500. Why it is? Because there are 15 missing values and count function always ignores missing values by default, right? And that's where we need to handle missing values. So generally what we do, if it's a continuous column, for continuous column, we replace missing values with the mean of that column. Mean is nothing but what? Average of that column. So what we will be doing is, we will calculate the average of the GRE score column, and then wherever the missing values we get, we replace those missing values with average of GRE score, right? So for example, university rating. For university rating, I will not find out the average because university rating is like what? Either it can be 1 or 2 or 3 or 4 or 5. That means it's a categorical data. It's not continuous data. So for categorical data, always remember we never replace missing values with mean or the average. For categorical data, we always use something called as mode, and I already talked about what is mode. Mode is nothing but what? Mode is nothing but the most repeated value. So if there is a missing value like this in categorical data, what we will do is we will replace that missing value, or we will handle the missing value by replacing that missing value with mode of that particular column. For example, the most repeated value for university rating is 4. That means the mode of that university rating column is 4. So wherever the missing values I get for university rating column, I will replace that particular missing value with 4. Right? So always remember, wherever there are continuous columns like this, you always handle missing values with mean of that column. And wherever there is categorical data like this or maybe like this, research is also categorical data. So for categorical data, we always handle missing values with mode. I hope you people remember what is mode. Okay, maybe those people who joined just now, I hope they are also getting what is going on here. But yeah, this is very important. If you understand at least one algorithm, right, the process of developing a model for at least one algorithm, after that you can go and you can just study the algorithm and directly implement it, because the process is always going to remain same. Obviously there are some steps which can be added depending on the data set, but more or less you will have to follow the same steps. Okay, if you get time, even I will try to show you general steps for developing the models, right? So let's see how it all goes actually. So I hope everyone is clear about what is the problem statement. Now, as I told you that we have 500 number of records, right? So Sharon is asking, sir, can you repeat what type of a data is GRE score? Okay. So the GRE score is actually, it's a continuous type of data, continuous data. Okay, see, data can be continuous. It means like what? As I told you that GRE score is out of 340, right? So someone might get 1 mark, 2 mark, 3 mark, 4 mark, 315 marks, 320 marks. So I am considering it as a continuous data. It's not a categorical data. What do you mean by categorical data? So best example, if I want to tell you what is categorical data. So categorical data, for example, gender column. Gender column is a categorical data. Either it's male or female. Other than this, there is no other value, right? So it is not like that here in this case. That's why I assume it as continuous. Is it clear, Sharon? So generally, whenever there is a continuous data, what we do is in a column, whenever there is a continuous data for that column, if there is a missing value, we always replace that missing value with mean or the average of that column. Like this, here it is missing. Okay. Now what? After this what? So as I told you that, and even in second unit we already discussed this particular point actually. Now you have your complete data set. Okay. Now how many number of observations are there? 500. 500 number of observations. That is 500 number of rows. Now this data we are going to divide it into training and testing. So before dividing this particular data into training and testing, we will divide this particular data into input and output. So till this, I told you this is what input, okay, and this column is our output column. So suppose x, this x will be assigned all these columns. So x is going to be my input. Okay, x is going to be my input, and I will represent this output column chance of admission with y variable. This is what generally we do. So one output and multiple inputs, right? Now, so obviously here also in input also we have 500 number of records, and obviously in output also we have 500 number of records. But after this, what we need to do? We need to divide this particular data set into training and testing. Why that we have discussed in the previous session? Because we want to create the model, we want to train the model, and then we want to test that model. For that, we will divide data into training and testing. And generally, it is 70-30%, or maybe 85-15, or 80-20. It all depends on how much data it's available to you, and it all depends on the policies of that particular company, or maybe decided by both the parties. Let's suppose we will divide this data as 70-30. So 70% training and 30% testing. So let me divide this particular data set into training data set and this one into testing data set. Similarly here also, training and testing. As I told you, 70% I am considering as training data and 30% as testing data. 70% as training data, 30% as testing data. It all depends on you. So 70% of 500, it means what? 350 number of records, right? So there are going to be 350 number of records here. Okay, 30% of 500, so remaining 150 is going to be testing. Similarly here also, 350 number of records, and here it is going to be 150. Now see, as I told you, x is what? X is input. Y is what? Y is output. So we will be making use of some variables like x train. So input training data and x test, input testing data. Okay. Then y train, output training data, and y test, output testing data. Now just try to understand here. After this, what we are going to do is, now from the training data, we need to create the model by applying linear regression algorithm, or for that matter, any algorithm. But as we are talking about linear regression, linear model here, so I will be making the linear regression algorithm first. So that linear regression algorithm we will be applying on this training data. See this one, which is input, and this one which is output. So I will take this as an input and this as output, and I will apply linear regression algorithm. Let me just highlight it with some different color. See here I will apply linear regression. On the data I am going to apply linear regression algorithm. And once I apply linear regression algorithm is going to give you one model, right? So generally we save the model with .pickle file. The extension is .pkl. Okay. How it looks like that I will show you later on. So this is how we are going to create the model. So this model we got from where? This model we got from our training data. Okay. So we have used this training data, that is input, and corresponding output of the training data is this one. Now what about testing data? No, yes, we created the model. Our model is and actually it has given us good accuracy for training data. Now there is a time to test that particular model. So to test that model, we will be testing the model with the help of testing input data. That means I will be making use of this particular data set as a test data. So I am going to pass this data set, that is 150 number of records, to this particular model as a input. And this model is going to give me Y value, that is chance of admission. Okay, and suppose I will name it as Y prediction. Right? So this is the result given by our model for this particular input data. Okay, so Y underscore prediction. This is the result given by our model. But for the same input data, see, I am the data which I am highlighting. For the same input data, we already have answers. That is this one, right? Which we named it as Y underscore test. So this result is given by our model, and this is actually the actual value of this particular input. So the difference between Y prediction and Y underscore test, we will find out. And whatever is the difference between them, that is going to be our error. Or we call it as, last time I told you, we call it as residual. So our target is going to be what? Our target is going to be to minimize this error or to minimize the residual. So if you remember, last time I talked about derivatives, right? I told you what is the practical application of derivative. So to find out the minimum. So this is where we will be making use of derivatives, right? So I hope you people have understood. This is what, see, whatever I am going to do now with the help of Python, I tried to show you the whole idea here, right? So maybe if you want, I will repeat it once again. It's simple thing. See, this is the process. This is what data we got. That data we will divide it into input and output. Once it is divided into input and output, we will divide that particular data into training and testing. How? That's what I have shown you theoretically. Once it is divided into training and testing, then we will apply algorithm. Like for example, here we will be applying linear regression. And once we apply linear regression on that, we will get the model. Right? And once the model is ready, we will test the model. So while testing, we will be making use of the test data, which we have already separated from the data set which we got from the client. That is 30% of the data from the input. That is 150 number of records in our case. So for this 150 number of records, this is the result which is given by our model. But the original result or the correct result was already with us. That is this one. So what we will do, we will be doing is we will go and we'll just find out what is the difference between them. And that difference is going to be the error. Ideally, it should be 0. If it is very high, we will go and we will try to minimize the error or the residue. This is how we are going to proceed. Now, just let me know anyone if you have any difficulty. Those who actually trying to listen from the start. Anyone any difficulty, any doubt? If you want, I will repeat the things again, or maybe I can explain the things in some other way also. That's also possible. Just let me know, because see, it should not happen that I will go and I will try to show you the code and at that time you are not getting it. It should never happen, right? Because maybe in the next session, what I will do is maybe suppose I will discuss support vector machine. Support vector machine can be used for prediction as well as classification. Even though it's a different algorithm like support vector machine, but the process is going to remain same. That's why I just make it a point that everyone is able to understand the process which I am trying to talk about here. Because this process is not going to change. It is more or less going to remain same. Okay. So pickle is Sharon is asking, pickle is a module or a package? Yes, it's a package, Sharon. What we will be doing is we will be importing pickle, and then we will be making use of pickle in our code, right? So yes, any other doubt? Are you people getting? Has everyone understood the flow, or you have any doubt? Can you please let me know? Because if you do not understand this one, then later on there will be difficulty to understand the implementation, right? Because see, everything, whatever we'll be discussing in implementation, that will be directly connected to this. That's why I'm just asking you the same thing again and again. Okay, Saloni is saying, okay, she has understood. What about others? Other people, can you just reply? 3, 4 more people, can you just reply me if you have doubt, or are you getting it or not? Oh, okay. So that's good. I hope then everyone is able to understand. Okay. Now, the first thing what we will be doing is, so whatever the flow I have shown you. So whatever the flow I have shown you here, now just do the same thing in implementation. The first and the foremost thing we will be doing is importing the data set. Okay. So let me clear everything and let me import the data set first. Okay, so here. Yeah. I hope everyone now clear about dataset. Let me go to Jupyter. Okay. Now see, uh, as I told you, I will be directly starting with the problem statement. So I hope everyone has understood the problem statement. Now see, these are the libraries which we are going to need. Okay. So I'm just going to input all the necessary inputs. So pandas you are aware about. I'm importing pandas package. NumPy we are going to need. Pandas we need because we need to import the data set. The data set, the CSV file which I have just now discussed, we need to import that particular file as a data frame. So that's why we are going to need pandas. NumPy, why we need NumPy? Because many times what will happen is there will be a need to change the shape of the matrix, to change the shape of the data set. Many times that will be needed, right? And to do some mathematical operations, we are going to need NumPy package. And to convert everything into arrays, we need NumPy package. So that's why it's important. Now, why we are importing this kind of a library, standard scalar? See, first of all, let me tell you why many people talk about Python, or why Python is important whenever we talk about machine learning, deep learning, computer vision, artificial intelligence, and any other field. Because of the packages, right? Python is really rich in terms of packages. So there is a package in Python which is called as Scalar. So some of you might be knowing Scalar actually stands for scikit-learn package. Okay, scikit-learn. Now scikit-learn is the package which is available in Python, in which you will get almost all the machine learning algorithms. Almost all the machine learning algorithms you will see which are available in scikit-learn package. And there are a lot of methods which are very useful, which are available in scikit-learn. So obviously, in your case, if you want to run the same code, I will share this code definitely, which is for implementation of linear regression. But if you go and if you directly try to run this code, it will not run in your case, because first of all, you need to install all these packages. Mainly, you need to install scikit-learn. I hope you people are aware about how to install any package in Python. So we have a command called as pip install and name of the package. So in our case, the name of the package is scikit-learn, scikit-learn. Okay. So I think I have discussed where to fire this command. So if you are not aware about, because see, you are going to see the same package again and again. How to install this package? Just if you are using Anaconda, navigator, just go to Anaconda prompt, and here you need to fire the command pip install and whatever the package you want. Right? Suppose I want scikit-learn package, and let me tell you many times, as there are different updations available for Python. There are different updations available in Python. What happens is the names of the packages generally change. Okay, that is one thing. And also make sure that which environment you are working in. So most of the times you will use base environment only for smaller application, but whenever you will work on real-time projects, you need to change the environment. By default, the name of the environment is actually base, which is available. Okay. So what I was telling you is many times you will see that the names of the packages are updated. So that is the command pip install and name of the package. Suppose if you are not aware about the name of the package, you always go and always search something like this py and what is the current name of the package. So if you want to see that, just type py and whatever the older name is or whatever the keyword related to that particular package, just go and Google it. Click on this. You will get a command, you will get the complete documentation for that package. That's why nothing to remember in Python. You don't have to mug up anything. See, what you need to do is go here, just copy this particular command, go to command prompt and paste it. Right? This is the command which is actually used to install scikit-learn package. But in my case, it's already installed. That's why I will not install it again. But remember, scikit-learn is really very important. Support vector machine algorithm. You talk about linear regression, logistic regression, decision tree, XGBoost, k nearest neighbor. Almost all the algorithms are by default available in scikit-learn package. So that's why it's very important. I told you how to install scikit-learn. Now why? Why are we making use of something called as standard scalar? If you people remember, sometime before only I told you that the basic requirement before applying or the basic need of any machine learning algorithm, before applying any machine learning algorithm, you need to make sure that your data should always be in numerical format. And another thing is that your data should be normally distributed. So just to make sure that your data is normally distributed, you are going to need some package, some method like standard scalar. What standard scalar is going to do is, standard scalar is going to scale down all the values to the same scale. It means what? See, if I go and if I try to show the input data once again, GRE score is out of 340, TOEFL score is out of 120, university rating is out of 5, SOP out of 5, LOR out of 5, CGPA is out of 10. If you go and if you try to check the scales of all these columns, they are different, right? 337, 118, 4, 4.5. If you compare each one of them, there is a huge difference between them, right? So it should not happen that when we will pass this particular data set to linear regression algorithm, it should not happen that GRE column will be given more weightage as compared to CGPA or LOR. It should not happen. Each and every column should be having equal weightage, right? So see, if there is higher weightage to a certain attribute, certain feature, because of that, again, your model is going to be overfitted model. And that's what we do not want. That's why what we do is we try to bring all the values to the same scale. And that actually will be done by this particular method, standard scale. What it will do, in simple words, if I want to tell you, it will apply some operations. Operations like what? For example, it will go and it will try to take the square root of all the values. Like this is what is going to happen internally. It will go and it will try to take the square root of all the values. Square root of 337. It will do this particular thing again and again till what? Till all the values are on the same scale or the difference between them is negligible. Right? What will happen because of that? Because of that, each and every column will be having equal weightage. So it will make sure that your model will not become overfilled. See, taking the square root is the example I am giving. It's not like that internally it is going to take the square root. It might take log also. Go on taking the log of all the values, right? All the values. Instead of square root, go on taking the log. Till what? Till all the values are on the same scale, right? So just to explain you the basic use of standard scalar, I have given that log or square root example, right? That's why we are actually importing standard scalar method from scikit-learn.preprocessing. See, once you install this particular package, and once you go and once you type sklearn dot and press tab button, you will be able to see a lot of methods. Let me show you. In my case, okay, I will have to import it first. Again, I will have to import that particular package. So let me show you what I'm trying to talk about is if I go and if I try to open a new notebook here, so let me check import. So what I have done is SK and I have pressed tab button. So see, now it has shown me option SK image or Scalar. So I want Scalar. Let me go and let me run it. So if it is installed in my case, this star will go, and it will show me nothing. That means it will not show me any error. Now see, there is no star. That means it is imported. If I go and if I type sklearn dot and press tab button, now it should show me all these things. So what was that? Okay, sklearn dot pre-processing. So I will have to use this particular keyword also. From is a keyword. Okay. So you go and you type from sklearn and then just go on pressing tab button, you will be able to see lot of numbers. So out of that, we are just going to make use of standards. I hope you people have got why we are actually making use of standards. Okay, like this, we're gonna need other packages. Train test split, we need it because we are going to divide our data into training and testing. So the method related to that is also available in Scalar, right? Then tax model, I'll be talking about this maybe in the next session. Okay, why we need it. So it's a SM is nothing but it's just a life or variable. For statistics, we need this. Matplotlib, I hope you are aware about. For plotting, we need it. Cybon, this Cbon is also for plotting. We'll be talking about. Okay, so this is nothing but all the necessary imports which we need for creating the model. Okay, and like this, I'll be making the pandas package to import this admission underscore prediction.csv file. What is this file? I already showed it. This file. This is the file which is named as admission underscore prediction.csv. Because as that particular file is already present in my working directory, that's why no need to give the complete path. I have given a relative path because I am already in the same directory in which that file is. See this one. Okay. So maybe I'll be talking about remaining libraries which are available and all the steps which I had discussed theoretically. All the steps are actually implemented here. So I'll be talking about all these steps maybe in the next session, and we will try to finish this in the next session, and finally we will see the model and how to make use of that model. Okay. So okay, that's what I wanted to talk about for today. You people can share your sheet numbers and names. I will stop here.